Hi, Mitch Wenger back with another video on data analytics and machine learning. In this video, we'll discuss various models, how we use induction and prediction. Hope you enjoy. All right, let's get started. What is a model? Well, we use models in all kinds of different professions. Architects use blueprints, engineers may build a prototype. In finance, we've got all kinds of financial models. Black-Scholes is an example that we use for pricing stock options. In systems, some of you may recall from your systems classes, we may use BPMN activity diagrams or UML class models or something along those lines. So we've got all kinds of models. And in data science, our model is basically our formula for estimating our unknown value of interest, or the target. So this may be mathematical, it may be a set of statements or rules, it may be some kind of combination of both. And as with the models that we use in other professions, we may abstract away some of the complexity of real life, i.e. some of the complexity that we have in our data. Interestingly, this often actually helps our model. As we move into prediction, we're moving and working with supervised models. That means we have some target attribute of interest, some target variable of interest. And we don't know what the value of it's going to be at the time we need to make a decision. But we need to be able to predict or estimate it. So, what can we find out that will help us predict the value of this unknown target or label? Basically, we want to minimize the uncertainty we have regarding the label value, or conversely, maximize the likelihood that we correctly predict the label value. Of course, we have additional considerations and constraints based on the nature of our problem. What is the cost of being wrong, for example? And what's the cost of being wrong in either direction? It may be more costly in one direction than the other. And of course, what benefit will we obtain if we are correct? We'll get into some of those issues as we move forward. Now, in data science, we talk about predictive models and descriptive models. We've worked our way through descriptive models. We used clustering to help see if we could describe our data a little bit and help us gain some insight. We looked at a univariate, bivariate, multivariate analysis. And of course, in predictive data science, we're looking to estimate that unknown label value. So things like credit scoring, spam filtering, fraud detection, and predicting the likelihood of churn are all examples of predictive models. Generally, predictive models can be categorized as either classification or class probability problems or regression problems, estimating a value. So like we mentioned, descriptive models generally help us gain insight into that phenomenon or process of interest. So clustering the churn data to see what we could find out about our different groups of consumers would be an example there. Now, one thing to keep in mind is the difference between predictive and descriptive model types isn't really as strict as our distinction here implies. As a matter of fact, you can use many of the same techniques both ways. In fact, sometimes a single model can serve both purposes, although most of the time you'll find that it doesn't do a real good job there, but it can be done. As you deal with data sets, you're going to find that you hear lots of different terminology that basically means the same thing. So in describing our data or describing your data, a lot's going to depend on who you're speaking with, what you're reading, what the reference discipline is. For example, we have an instance which represents one record in our data set. And as you can see, we can refer to that as a number of other terms. It's an example in our data set. It's a feature vector. It's a case. It's a row in our database table. It's a record in our file or on our worksheet. It's a data point. Next, we have the data set. Again, you'll hear it referred to by other terms such as table, a database table, for example, the worksheet in our Excel workbook, data space. Next, we have the features of our data, and these are the attributes that we want to explore. In stats, you may call them independent variables or explanatory variables or the predictors. Again, just depends on which discipline you're coming from. And then finally, we have our target. And the target is often called the label or label value. And back in stats, we'll call it the dependent variable. Now, those items you see in pink are probably the ones you're going to hear most often when talking with data scientists, especially hardcore data scientists. Of course, as we know, independent variables aren't always independent of each other and often are not independent of other things as well. And likewise, dependent variables may not be dependent on all of the explanatory variables. We'll wrap up this discussion by talking a little bit about induction. Induction is a philosophical term that means working our way logically from specific instances to general truths. In data mining, we do this mathematically. Now, of course, the models aren't correct 100% of the time. And we build the models by using training data. So we use the training data to build the model or induce the model. That training data is labeled. So the labels are the target value of interest, and they're labeled already because we already know what that target value is for our training data. So induction is in direct contrast to deduction. And in particular, the hypothetico-deductive logic model used so often in scientific research. Using deduction, we develop theories. Now, these can be big T theories or small t theories that help us understand the world. From those theories, we create hypotheses, then predictions. And from there, we can test those predictions a number of ways. Now, of course, many of these theories are initially proposed as a result of observation of specific instances, i.e., induction. The apple fell on Newton's head. Induction led to his postulating on the theory of gravity, and so on down the line. And of course, just like our induction model, deductive logic models aren't always 100% correct either. So that's it for this discussion on moving toward prediction. I hope you found it informative. Be sure to check out the other videos in this series.